Hey everyone, welcome back to John Codes. This is part 3 of my Kubernetes for Beginners series. In this video, we're going to be talking about pods and deployments. And if you remember from the last video, we deployed a cluster using kind. You should have that up and running. We talked a little bit about basic Kubernetes objects like namespaces. Here we'll be talking more about how to actually deploy your apps. Make sure to like, comment, and subscribe. Join the Discord if you have any questions. Let's get into it. Now we need to make sure Docker is running. I see the icon up here, and it is running. We need to make sure our kind cluster is up. If you don't have one, you can simply do kind create cluster, and this will quickly spin up a new cluster for us. Now that we have our cluster up and running, let's actually deploy an application. Now remember, Kubernetes runs containerized applications in the form of pods, and these are usually just Docker containers. Usually Docker is the container runtime for a Kubernetes cluster. But in short, pods are just configurations of Docker containers. Now for this example, I'll be using the default namespace. We can do kubectl get namespaces and see that this cluster has the default namespace and then several system namespaces that the cluster uses. But for this video, we'll just use the default namespace. That's just fine. Now we can use the Kubernetes command line tool kubectl to deploy our application and get a quick pod up and running. So let's look at our pod YAML. Here we're declaring v1, it's a pod, and some metadata. The name, we're just going to call it my pod, and some labels. Now labels will be a little more important later on, but for now you can just say the app is my app. And then the spec. The spec is really important. This is actually what determines the containers that are running inside of the pod. And this pod will just have one container, and we'll call it my container. Now the image right here is also really important. This could be your application image, your Docker image, your development image, or some public image like BusyBox or Nginx. Now we'll be using BusyBox here, and that's just a really lightweight Unix-like container. And the command. Now since BusyBox is just a lightweight Unix container, we need to give it a command to actually run something. Now what this will look like is each command in quotes and comma delimited for the arguments. So we can say the shell and it'll have a command, and we'll give it the whole command here. We'll just echo hello world, and then we'll do something else. We'll just sleep for 20 seconds. And we can use this file and apply it to the Kubernetes cluster, and it'll create our pod for us. So kubectl apply our file, and this is pod.yaml. And we can see that pod my app was created. And we can kubectl get pods. And we can see that this pod is running, and it's been running for 8 seconds. Now we can even get the logs from that pod running, and we can see the hello world that gets printed. So we can kubectl logs my app. And we see hello world there. Now if you had a pod that you needed to debug a little bit longer, see some logs going, you can kubectl logs my app -f, and that'll actually follow the logs and tail them as they're coming in. This pod doesn't have anything else logging, so we just see nothing coming back in. Control C to get out of there, and we're back to our terminal. Now let's look at and see what that pod is actually doing. Now we can see that we have entered a status crash loop backoff, and that it is not ready. And the reason for that is we ran our command, we ran hello world, and we got to sleep. It slept for 20 seconds, and then it just exited. The container is done. It doesn't have any more work to do, so it finished up. Now remember that a pod is essentially just the building blocks of a bigger application, a bigger deployment, which makes up the whole cluster. Now, what's happening here is the pod itself, the pod object, doesn't have any self-healing mechanisms or anything to reinstate it. The pod essentially just finishes and is done. And we can see what happens if the pod gets deleted. So let's just run kubectl delete pod my app. And we can see that the pod my app is getting deleted, it's getting torn down. And once that finishes, we can look at the pods, kubectl get pods, and we see that it has no pods. We can even watch that and see that Every 2 seconds, it's trying to see if there's any pods, and there just are none. That pod isn't coming back. It's been deleted, and that object is just gone. There's no self-healing here. There's no fail-safe if that pod is accidentally deleted. Now, how do pods get deleted? It could be a problem with the worker machine. It could be a network fluke. It could be any number of things. In order to fully take advantage of Kubernetes features, we need to deploy a more advanced object. This will give us more fail-safe things like self-healing and getting our pods reinstated if they get deleted. Now, there are a lot of ways to do this, but in this example, we'll use one of the more popular methods, and this is just the Kubernetes deployment configuration. Our deployment will let the Kubernetes control plane know to schedule our application onto worker nodes and to monitor the instances for any problems. This is what provides the self-healing and fail-safe mechanisms that make Kubernetes so powerful out of the box. Now let's take a look at a deployment YAML and look at what we have that gives us the fail-safe mechanisms and self-healing things that Kubernetes is known for. So I've collapsed a few of these sections down in the YAML just so we can go through them one by one. First we have API version apps v1. The kind, it's a deployment. The metadata is important where we have the name of the deployment itself. We're just going to call it my nginx. This will be an nginx pod. And the labels. And we're saying the app is nginx. Now labels are important for the control plane to know and match pods with how things should get replicated, how things that fail should come back up. It uses labels to match a state that it knows about, and it uses those labels to achieve that optimal state. And we can look at that in the spec here. The spec, we're saying replicas 3. Essentially what we're saying here is we want 3 nginx pods to be up at all times. If for some reason one gets deleted and it's been labeled app nginx, it'll come back up and we'll have 3 of those. Now the selector, this is important because this is what actually matches the labels up. We want to match that up with pods for the deployment. And the template, metadata labels, here's that label again so that we can match and get replication, get the self-healing. And our spec, we're saying pods in this deployment will have containers. The container name will be nginx, and the image will be nginx 14.2. So now, let's head over to our cluster and deploy this. So we can say kubectl apply file deployment.yaml, and this starts spinning up, and we can see what deployments this cluster knows about. We can say kubectl get deployments, and the deployment name my nginx, and we see ready are 0 out of 3. It's still spinning up, and it's been up for about 9 seconds. So kubectl get pods, and we can see all 3 of these pods. They're all now ready, and it's good to go. So now, kind of like what I was talking about, what happens if one of these gets deleted? We obviously want the state of 3 pods to be up at all times. So we can kubectl delete pod my nginx, a little tab completion, and we'll just delete that first one. So that finishes deleting, and we can look and see what happens. Kubectl get pods, and we can see that instantly it brings up a new pod. It's been up for 21 seconds. This is the new one, and it tries to maintain that state based on the labels that you match for the pods themselves in the deployment. So this is super powerful to enable your applications to be highly available and constantly up. You don't have to worry about your scripts or things to make sure that things are running or up and going. Now I want to talk about another thing that can be really powerful when you're debugging things or looking into Kubernetes objects, and that's the describe command. So we can describe any object that Kubernetes knows about. We can describe deployment my nginx. And we get a whole dump of things here. We get labels and annotations that Kubernetes put on this YAML, and we also get events. The events in the describe here are really powerful to know certain things that the nodes might be doing or the control plane might be doing. This is a really powerful tool to use when debugging things and looking into what the actual cluster is doing. So now the really powerful thing about this is our YAML here. We can use this to scale and upgrade and do all kinds of things with our deployment right here in the cluster. So let's say that we're having a ton of traffic and we actually need to scale up our replicas to 5. We just replicas 5 there, and we come back over here, kubectl apply file deployment.yaml, and it deploys it. And instantly, the replicas that the deployment knows about scales it up to 5, kubectl, get pods, and we can see now that we have 5 Nginx pods running. This is great. This is scaling up almost instantly with just one line, changing one line in the YAML. So let's say that there was a major bug in Nginx 1.14.2, and we need to bump down for a little bit to 1.14.1. Now, upgrading, downgrading, this is super easy with Kubernetes. All we have to do here is change the version, 1.14.1, come back over here, kubectl, apply file, deployment, that applies, and let's look at the pods. And we can see it's creating the containers, and this will do a rolling deployment. Generally, the strategy for Kubernetes is sort of a canary strategy for deployments. It'll do one by one and start to roll them so that there's never any downtime for your pods. And we can see that we have all 5 running now, and these are all the new version that we defined. Upgrading and downgrading is super easy with Kubernetes. So this is great. We've deployed a cluster, you understand the basics of Kubernetes and how it works, and now we've deployed an application. So what's left to do? One of the biggest things and most complicated and that really confuse most people is networking and load balancing in Kubernetes. Essentially, how do I get access and expose my applications and services in my cluster to the outside world? Now, that's a little out of scope for this series, especially since we've been using kind, but what I would recommend is actually heading over to the Kubernetes documentation and looking at their getting started and concept guides. You can go into concepts, and we can see that there's a whole section on services, load balancing, and networking. This is really good information, but is a little out of scope for these videos. Additionally, I would recommend signing up with a new email address for Google Cloud Platform, and they give you some credit, and you can use that credit to get a GKE cluster. That way you can have a real production-ready cluster that you can deploy actual load balancers with, that you can then see how application networking works, and how you can actually get from an end user through the load balancing networking to your actual application. Again, unfortunately, that's a little out of scope for these videos since we've been using Kind, but Kind is a great tool for deploying local clusters and seeing how your code actually plays with Kubernetes. Now, there's also tons of great resources on GitHub. You can look up CKAD, which stands for Certified Kubernetes Application Developer. These are great exercises and all kinds of repositories on here for learning little tips and tricks for tweaking and configuring Kubernetes and getting it to do what you want it to do, even in some obscure circumstances. Taking the certification exam can also be a really good way to study, learn more about Kubernetes, and get recognized for your knowledge. Finally, I would recommend this repository, which is Kubernetes the Hard Way. Now, this is for the hardcore users who want to know exactly how Kubernetes works. It's very in-depth, and what it does is it takes you step by step deploying the individual components of Kubernetes by hand yourself in the public cloud. Now, this would be deploying the actual control plane yourself, provisioning the nodes yourself. It's very in-depth. It's very, very good. I recommend it for anyone who wants to learn more about the inner workings of Kubernetes. Well, that about does it for this video series. You've learned the basics of Kubernetes, how to deploy a local cluster with Kind, and how to deploy your application code on a cluster with Kind. Make sure to like, comment with what you want to see next with Kubernetes, and subscribe, share this with people. It really helps out the channel. I will see you guys next time.